When you hear the word atom, what comes to mind? Probably immense power, maybe some controversy, right? But the story of nuclear tech today is, well, it's splitting into two fascinating paths. We're talking about a tale of two different scales, one big enough to power our cities, and one small enough to fight disease inside a single cell. Okay, let's dive into this.
So, you see this, a giant power plant, and you immediately think of energy for the grid, of course. But what if I told you that the very same science is also behind some of the most cutting-edge cancer treatments we have? Today, we're going to explore both sides of that atomic coin.
So here's our game plan. We're going to start with the big one, safety, and the totally new standards that have come into play. Then, we'll shrink things way down to see how the atom is used in medicine. After that, we'll connect the dots and look at the global challenges they both share. And finally, we'll see how all of this fits into building a greener future.
Look, before we can even begin to talk about all the potential here, we have to address the elephant in the room. For pretty much everyone, when it comes to nuclear, safety isn't just a priority. It's the only place to start the conversation.
Okay, so this slide is really key because it shows a huge shift in thinking. After the Fukushima accident, everything changed. The old way of doing things on the left was all about preventing a single piece of equipment from breaking down. But the new standard on the right, it's on another level. It was born from a much tougher question. What if everything goes wrong at once? What if a massive earthquake and a tsunami hit at the same time? You see the difference? It's a move from preventing one failure to managing a total catastrophe.
And this is what that new standard actually looks like in the real world. We're talking about concrete, physical upgrades, making plants tough enough to handle the absolute worst that nature can throw at them, having backup plans for when multiple systems fail at the same time, things like preventing hydrogen explosions, and even adding defenses against things like a direct airplane impact. The whole idea is to build layers upon layers of redundant safety.
All right, so that's the massive city-powering scale. But now we're going to do a complete 180. We're zooming way in, from the macro to the micro, to a field where that same nuclear tech is used with unbelievable precision, medicine.
I know, it sounds like a crazy leap, doesn't it? How on earth does the same technology that keeps the lights on also power a life-saving medical treatment? Well, the answer is all about learning how to harness radiation in a completely different and much more targeted way.
So this slide basically breaks down the two main approaches. On one side, you have external radiation. Think of it like a sniper rifle, where beams are aimed with incredible precision at a tumor from outside the body. But then you have internal radiation, which is just fascinating. This is where doctors introduce tiny radioactive substances, called radioisotopes, into the body. They act like little guided missiles that hunt for and attach themselves to cancer cells, fighting the tumor from the inside out.
And this, well, this is why it matters. This isn't a diagram, it's a real patient. On the left, you see all those dark spots? That's cancer that has spread. Now look at the right. After the therapy, it's a dramatic, visible reduction. This is the power of the medical atom, right here. Precision that makes a real, life-changing difference.
So we've got these two incredible applications, powering cities and treating patients. They seem like they're worlds apart, but you'd be surprised. They're actually connected by a web of shared global problems. We're talking about things like supply chains, costs, and finding people with the very specific skills to do the job.
Let's stick with the medical side for a second. Just look at this flowchart. The journey for just one dose of this stuff is mind-boggling. It goes from a mine to a special reactor to a processing facility and finally to the hospital. And a country like Japan depends almost completely on imports for these critical ingredients.
And that's the problem. That reliance makes the whole system incredibly vulnerable. There are only a handful of reactors in the world that make these isotopes, and they're getting old. So when just one or two of them have an unexpected shutdown, bam, you get instant worldwide shortages. And that means patients have their scans and treatments delayed. The whole supply chain is just really fragile. Now, let's flip back to the energy side. This chart tells a really clear story. The blue bars are the original cost and time estimates for new power plants. The orange bars, that's the final bill and timeline. You can see the trend pretty clearly. Projects in the US, the UK, and France are ending up years late and billions over budget. This isn't just a hiccup, it's a systemic problem.
And this is the common thread, the thing that ties both medicine and energy together. The root cause for all these delays and fragile supply chains is a breakdown in the human infrastructure. For decades, we didn't build many new plants, so the specialized skills, the unique manufacturing parts, the expert workforce, it all just kind of faded away. And you can't just flip a switch and bring all of that back overnight.
So, with all these challenges, you might be wondering, what's the path forward? Well, for Japan, the answer is tied directly to the global push to fight climate change. And that's where this national strategy called the Green Transformation, or GX, comes in.
Now, you gotta understand, GX isn't just some small energy policy. It's a massive plan to shift the country's entire economic and social structure. The goal is to move completely away from an economy built on fossil fuels to one built around clean energy. It's a huge undertaking.
And this right here is the most important takeaway from that whole strategy. You know how the debate always gets framed as a choice? You can have renewables or you can have nuclear. Well, the GX policy basically says that's the wrong way to look at it. To power a modern economy, especially with growing demand from things like electric cars and AI, you're going to need both. It's not or, it's and. Renewables and nuclear working together.
And so, that brings us full circle. We've seen the two faces of the atom. One is this massive source of power, now being built with more safety than ever before. The other is this incredibly precise medical tool that saves lives. We've also seen just how fragile the human systems needed to support them can be. Which leaves us with the big question. For both our health and our planet's future, how do we balance the incredible promise of this technology with the profound responsibility that comes with it?